Hi, I'm Dave Hobbs, Delphi Technology Senior Field Training Instructor, and I want to give you another one of our series from our Delphi Parts Cast called Avoiding the Defective Diagnosis. This one today is going to be called the Avalanche of Assumptions. We're going to get into a 2007 Chevy Avalanche that I was called in on as just a second set of eyes for helping a local repair shop that I deal with sometimes. It does a lot of favors for me, deal with a very difficult diagnostic problem. They had this 2007 Avalanche, I think it was a 6-liter. It had a traction control slash stability control light on. So it was like 1 year early before, or several years early actually, I think, stability control became standard in 2012 or required. So this was a little early adopter of stability control, but it had it. And what the customer was saying was, besides the light on, where it had the picture of the tire skidding, that yellow light, it had a power loss associated with the light. So basically, everybody working on the vehicle had an assumption that we had an issue with traction control, because when you have a power loss, you're doing torque management if that light comes on. That's the assumption. So it was very intermittent, and the independent repair shop was having a difficult time trying to catch it in the act, but they did get a code that was a C code. So it's a chassis code, a C0561. So whenever that track light, stability control light, would come on, and you would experience a lack of power, basically limited throttle, due to the assumption that we had a difficulty with either traction control or stability control, or sliding somewhere, it would set this C0561. And so I came across the vehicle. I just happened to be in the town where this shop was, and he called me on the phone, just wanted to pick my brain. And I said, "Hey, I'm in town, buddy. I'll come by. I've got a scanner with me. We'll do some work on it together, and we'll figure out what it is." So I show up, and he gives me this printout of the code description. And it says, for the C0561, it says system disabled, information stored, invalid serial data received. So, I'm picking out keywords in here: disabled, serial data received, but it's invalid. So I'm kind of thinking along the same lines, assuming along with the technician and the shop owner that this Avalanche has got a serial data bus problem. And I know the shop kind of assumed that too, because they had the DLC hanging down, and a few inches back from it. Now this is an '07, so it's pre-CAN, 1 year before all the vehicles became mandatory CAN for at least powertrain and chassis. And so here, laying down just behind that dangling DLC, was the stripped out, they had the black tape removed around the little star connector. So they had been probing that star connector, removing the connector, probably measuring the resistance to see if we're shorted to ground on any of the nodes going to that star connector that connect all the different modules on the serial data bus together. This was a J1850 type serial data bus, or as GM would call it, the Class 2 serial bus. And so that's where they were headed, but also they had the button just above the console on the front of the IP, right in the middle. They had the button that has a little tire skidding icon for activating or disactivating, I should say. It defaults to on when you turn the key on, but you could deactivate the traction control in case you're in the winter and you're trying to get out of a snowdrift and need to slip the tires a little bit. So they had that kind of dangling out as well, thinking, well, maybe the light's coming on and we're limiting traction falsely for whatever reason because the switch has got a problem. So they're thinking something with a traction control or stability control, or something with serial data bus. And that's what the code was kind of describing. So I'm thinking, well, they would have found it hopefully by now, because they've been working on it for several days. So I'm thinking the next thing to do is look for TSBs and so forth. And we go to the trouble tree before we go to the TSBs. They had that printed out as well. And early on in the trouble tree, it gives a little line, which I didn't pay that close of attention to. I got to admit, I'm like probably a lot of you watching today. Instructions, directions, we sometimes reluctantly follow and read them, especially carefully. But it basically said diagnose any other vehicle DTCs before attempting diagnosis of the C0561. Well, I went ahead and ran the DTCs, and I didn't see anything that stuck out. I mean, I'm looking for C codes. I just see this C0561. So we go on, and I actually went ahead into IATN. If you're not a member of IATN, you might look into it. It's the International Automotive Technicians Network. So it's basically a forum, kind of, if you will, Facebook for technicians, not for social reasons, but to post the problems they're having with vehicles. And other technicians receive emails that they select categories that they're interested in. And so anything that's an email of another technician out there, and there's like 40,000 strong in IATN, any other of these other technicians post a request for help on a particular vehicle, you kind of scan your emails every day and you go, oh, I think I've had that same problem in my shop. So you open the email up, I know I've had that problem, and the golden rule, do unto others, you want others to do to you. You click on it and you respond back and say, hey, you're not going to find that problem where you're going. You need to look at G105. It's the little ground behind the right head or whatever. Those kind of things are really helpful in IATN. It's tech helping techs. And there's also forums that you can post opinions and trouble cards and so forth, and just basically general things, what you're doing in your diagnostic routines. Very, very effective if you're a sponsoring member. It's free to join just to post your problems or help other people with problems. I believe if you're a sponsor member, it's like $45 per quarter. And then you can look at historic cases and look up, by like a case argument, search argument, and find a lot of times cases where 6 months ago, a year ago, some technician received 20 requests or 20 responses for the request to help on a problem like this, C0561, and 2 or 3 of them, like, boom, that they were like perfect. They solved the problem. So pretty good organization. I went into it. I'm a member. And I put in the C0561, and I found 2 hits. And one was kind of ambiguous. I wasn't sure where it was going. But the other one, the guy said he fixed it, get this, of all things, by replacing E85 fuel with regular gas. Now, this is a flex fuel vehicle. I actually looked at the gas cap on this '07 Avalanche, and it's got the yellow cap. So I'm going, well, it's designed to do E85. So what's the big deal? So I thought, well, maybe this is one of those IATN cases where there was some misunderstanding, miscommunication, and the solution wasn't articulated accurately when they closed the case. Who knows? So sometimes you take some of those advice on IATN and other forums with a little grain of salt, but on the whole, they're very helpful. So I kept it in the back of my mind, the drivability issue, E85, what the heck? But what the heck's drivability got to do with the stability control and serial data issue? So I went on, I looked for any other codes. I decided to do go into generic OBD2 and look at pending codes. Now, you may not always see pending codes in some scan tools if you do like an all code, all module check. So I dug a little deeper, just kind of the drivability world, thinking, well, one guy fixed the same problem with changing the fuel from E85 to regular 87 gas. And so I went into the generic, I pulled up the pending codes, and sure enough, there were 2 pending codes. Now, there's no mill, these are pending codes. In other words, they haven't set a second failure in order to turn the malfunction indicator light. The check engine light was not burning. Just occasionally, the stability control / traction control light. And by the way, in road testing, for about 3 hours, actually. So as a consultant, as a trainer, I've got that liberty. I realize you as a tech or a shop owner usually don't have that luxury, but sometimes you got to take it. I didn't have the problem occur. So in all the hours I drove the vehicle, nothing occurred except for it started raining. Now, this is Southwest Florida where I'm doing this case study, and in the summer when it rains, it's hot, and a little bit of oil on the road. The recipe is slippery surfaces. So I thought, what the heck? Let's stomp on the accelerator of this V8 and make it break the tires loose, and I'll see if the traction control works like it's supposed to. So I slam on the accelerator, I break the tires loose, a little burnout, and this was really easy in the slick rain, and sure enough, the track light comes on, and the power goes away. It goes back to a reduced throttle. Well, this light's working how it's supposed to. So I let off the throttle, regained my traction, traction control light goes off like it's supposed to, and the power comes back to the engine. So I'm thinking everything is fine except a couple of lean codes, P0171 and P0174. So both banks, this V8, at one time had a little bit of a lean issue. So who knows? Maybe somebody did something when they were diagnosing it, or it's unrelated. So we go on, all right? So I look at TSBs, find nothing related to anything. And then I look for PIs. Now, if I've mentioned PIs in my presentations and training classes, I mention them all the time. As an old tech advisor back when Delphi was part of General Motors, I wrote PIs. PIs is preliminary information. They're basically bulletins that are put in very quick. They've not been fluffed and buffed and sent through all the regiments of documentation quite like a tech service bulletin. But most of the time in your aftermarket service information, whether it's Identifix, Mitchell on Demand, Repair Point from Delphi, All Data, all those motor information system, all those aftermarket information services, they're pretty good about picking up all your TSBs and pretty much most PIs. But the PI issue is kind of a corporate thing within General Motors, so not every PI is published. So how do you get it if you're an independent tech trying to get all the information you can to fix a vehicle? Well, go visit the General Motors Factory Service Information website, the SI 2000. Where do you find it? Where do you find any OEM's service information? That's not free, but it's a reasonable price. Pretty much every OEM places their service information. That's the same info that dealer technicians look at on a daily basis. You, as an independent technician, can purchase a 2 or 3 day short-term subscription, a month or a year-long subscription, whatever your budget allows. For the 2 or 3 day subscriptions, they're typically only about 20, 25, 30 bucks. So if you're spinning your wheels and you think maybe the schematic in your aftermarket service information resource is incorrect, or you're looking for this mystery phantom PI that maybe might help you solve the vehicle problem, if it's a General Motors product, for example, you need to go to the factory website, pony up the 20 or 30 bucks, and have 2 or 3 day subscription, just like the factory techs have, and oftentimes you can get yourself out of trouble. So I have a year-long subscription to the SI 2000, so I logged in. And sure enough, there was a preliminary information, a PI, that pertained to this problem that wasn't in my access to aftermarket service information that I use. So I looked at this PI that had something to do with the C0561, and it was very emphatic about what it said in the trouble tree. I kind of glossed over the trouble tree, but man, it was like in bold letters, kind of slapping me around saying, you really need to pay attention to this. It says, address any other conditions such as emissions DTCs prior to addressing a stability control DTC. In this example is the C0561. So I thought, I better pay attention. They mean business. They're really trying to get my attention. I was assuming everything is related to chassis issue or serial data because that's the description of the problem in the trouble tree as far as the description of the code, and that's the nature of C codes, all right? So what the heck? I'll go ahead and look at the P0 174, 171 for the lean codes on both banks. So I threw my scanner on there. I started graphing the fuel trim and the O2 sensors for both banks. And like my eyes pop wide open because both banks are 30 positive. We're positive 30, 28, 25, 30, hanging solid. Both banks. That's richening the mixture when you see the positive number because we're assuming, there's that word again, we're assuming it's lean. So an O2 sensor that is sensing a truly lean condition, low fuel pressure, big vacuum leak, restricted injector, something along those lines will have a low O2 voltage. That will, and as you're a decent drivability tech, you know that relationship between O2 voltage and fuel trim. So my total fuel trim, I'll define that. That's the short-term fuel trim where we tweak the air-fuel mixture based on real-time movements of that O2 sensor, combined with the trend we see of the O2 sensor over a longer period of time, which is called long-term fuel trim. So it's adjustments to the base pulse width of the injector. And you add the two together, so if one's a negative, one's a positive, you add those two integers together. So if you had a negative 10 and a positive 5, you would have a total fuel trim of negative 5. Negative 5 plus positive 10 be negative 5. In this case, short-term and long-term were both high numbers, so we were seeing positive 30 on average. That's high. I call that through the roof. That means that we must be, the ECM's thinking it's really, really lean. I look at the graphing of both my O2s, they're like in the basement. They're like 0.1, 0.2, 0.25, 0.15, just kind of toggling around there. So I'm thinking we could have bad O2 sensors, both of them, probably not. We could have a big, huge vacuum leak. My hearing's still good enough I can hear a bad vacuum leak. I didn't hear anything, the engine running. And so I thought, well, maybe there's some false air. If you have any air that gets in that the mass airflow doesn't know about, like maybe some duct work before the mass airflow or after mass airflow, whatever, you could have a condition where the ECM thinks or assumes it's lean, and so it adds more fuel. In this case, I did what every other tech would do. Let's check out the air fuel system, see if I can richen it up with some starting fluid into the intake. And if the O2s respond, they go high, they start switching, they start going 8 tenths, 7 tenths, and the fuel trims come down, then my O2 sensors are working. We're just sensing a lean condition because maybe it is lean, maybe it's got low fuel pressure, who knows. So I go to take the hoses loose at the mass airflow sensor, the big ductwork over to the air intake to the throttle body. And I'm like, when I got to grab a screwdriver, I got my pocket screwdriver, I might be able to bump that worm drive hose clamp loose good enough to get a little bit of starting fluid in right there after the mass airflow. I don't want to spray starting fluid or gum out or something like that before the mass airflow. It might damage the mass airflow. But after the mass airflow, I can do it. All of a sudden, my eyes bulge, and I go, geez, I don't need even a pocket screwdriver to loosen this hose clamp. It's already loose. In fact, it was loose as a goose at both ends. At the side of the ductwork that went to the throttle body, I could just spin the worm drive hose clamp. At the side going to mass airflow, same story. In fact, as I was monkeying around with my screwdriver and that ductwork, I actually kind of jarred it around, which was very easy because it was so loose. And the engine changed speeds. And as it did so, and all this is registering, I'm thinking to myself, 2 hours ago when I was driving this thing, a little mental note, not the best idle. It wasn't like a dead miss, but it was kind of one of those little bit of a rough idle misses. It's like, well, maybe it's an old vehicle, high miles, who knows? We're not after idle quality. We're out to fix what? A C0561, assuming we have a traction control, stability control, or serial data problem. In this case, none of the above was true. I actually then tightened the hose clamps at each end of the induction tubing between the mass airflow and the throttle body. Guess what went off? Oh, by the way, Murphy's Law, right in the middle of the process, actually better than Murphy's Law, actually kind of a prayer answered, right in the middle of my diagnostic process, finally, that light came on, and not for low traction either. That light meaning the light for the C0561, the stability control / track light. So that came on when I was monkeying around with it, and then when I tightened the hose clamps, cycled the key, light was off. Also, I cleared the pending code for the 171 and 174. Drove the vehicle several hours. I had that luxury, being a tech, just helping somebody else out, not on the clock or flat rate myself. So drove it, was convinced, fixed the issue. It all made sense later. Now, if you're a Toyota tech or other Asian vehicles, Toyota I know is known for this, they've been doing this for years at this point. So by 2007, they have traction control, stability control, tire pressure monitoring systems, anything that could mess up the powertrain engine management that's related to chassis will turn on a whole Christmas tree of lights related to problems such as this on those vehicles. And I remember reading a Dan Marinucci Motor Magazine article about this. So it's amazing how things start coming back to you when you start slowing down from the assumptions and getting tunnel vision on a particular problem and going back to a lot of information you've learned in training classes and reading magazine articles. And then another thing, Jim Moore, senior Delphi instructor way before me, the old gray-haired fella, he told me years ago in a training class, always diagnose the P codes first. Well, the mill wasn't on, so I didn't initially look at that, and neither did the tech that spent 3 or 4 days working on the vehicle before I got it. So I knew it was a simple fix. I knew that a tech would be embarrassed that they missed such a simple fix. So I tried to think of a really complicated way of basically giving the story I just gave everybody watching today. And it's like, nope, I just got to say as it is, but I'm not going to say it harshly or anything, or call the guy a dimwit, because the guy's a very good tech. So I what's my best explanation? Hey pal, this can happen to anybody. I didn't get 3 words out basically. He kind of knew where I was going. In the back of his mind, he saw that. In fact, he said, I saw those loose hose clamps. I didn't think much of it because it wasn't related. Now, here's the solution for the defective diagnosis, for the assumptions here. Number 1, never assume anything. And number 2, always go over all your DTCs, every module, every code, and document. Things you don't think initially that are related to each other are related. Here's the relationship in this system, by the way. And engineers have subsequently, after this model year of vehicle, have gradually began to kind of come to their senses, so to speak, and think, what, maybe an O2 sensor reading lean is not going to upset the apple cart when it comes to engine management. But here's the tie-in between stability control and engine management. So the mill for check engine for emissions and the stability control light. Stability control requires that you do not only application of the brakes when you're going through a corner, understeer or oversteer, but the first recourse for any stability control system is called torque management. Torque management means we've got to get into the throttle by wire. We've got to control that system because we're losing traction. We're losing control of the vehicle. So you're going to let off the gas. Well, with throttle by wire, the driver doesn't have to let off the gas. The driver can have their foot to the floor on the gas pedal, but the ECM being advised by the ABS module, which does stability control system work, is going to say, I need some torque management. I need the torque reduced from this engine so I don't lose control. So that was why the customer, when that light would come on, was losing engine power. That's the way it's supposed to work. But in this case, not because the vehicle was in a skid, but because the ABS module had seen on the data bus, the Class 2 J1850 data bus, it's seen the fact that the engine control module had a little issue with drivability. Now, would it cause the ECM not to be able to control the throttle by wire? Not at all. And that's why in software, in more subsequent later model years for these GM V8s, they've tweaked that and made it so it's not quite so vulnerable. But like I said, if you're a Toyota tech, you've probably been down this road. But if you do GM and Ford, Chrysler, Domestics, and other Euros or whatever, kind of new information. So whenever you see an engine management issue and you also got a chassis control issue, always think there could be a connection, because there is a connection between the two together. So all codes, all modules, number 1, preliminary visual inspection. Even if it's not necessarily that system, is not a bad idea. Looking for that dirty battery cable, the loose fan belt, the blown fuses, even though you think that's not really germane to what I'm working on today. And then finally, you can never have too many resources. Factory information, I got my PI that way. And of course, IATN and other good organizations like that. And finally, read every word in every flowchart, because those engineers, sometimes they make mistakes. They do have information oftentimes that will help us save the day. So hopefully this will help you save a little grief in making too many assumptions and avoiding that defective diagnosis. I'm Dave Hobbs, Senior Field Instructor for Delphi Technologies. Check us out on DelphiAftermarket.com. If you have any questions about this case, field study, or any other thing we've talked about in the Delphi Partscast, please visit us. Give us an email at delphi.podcast@delphi.com. And as always, check us out on YouTube. A lot of training videos and tech tips to help you out. God bless you for watching. Dave Hobbs again. Hope to see you soon.